A satellite or artificial satellite is an object, typically a spacecraft, placed into orbit around a celestial body. Satellites are a vital part of our infrastructure, helping us to use GPS, access the internet, and support studies of the Earth. For centuries, humans have looked to space and the stars for answers. The fascination is more than philosophical, it's coupled with the need to solve problems here on Earth. Today, there are seemingly countless benefits and applications of space technology. Satellites, for instance, are becoming critical for everything from internet connectivity and precision agriculture to border security and archaeological study. Satellites have a variety of uses, including communication relay, weather forecasting, navigation GPS, broadcasting, scientific research, and Earth observation. Additional military uses are reconnaissance, early warning, signals intelligence, and potentially weapon delivery. The growth in the number of satellites over the last decade was mainly driven by the development of the smaller CubeSat, which allows a large number of small-sized satellites to launch at the same time. However, earlier rockets were used only to launch one or two satellites at a time. The top 10 countries which are dominating the satellite industry are USA, China, Russia, UK, Japan, India, France, Canada, Germany, and Luxembourg. Right now, there are nearly 6,000 satellites circling our tiny planet. About 60% of those are defunct satellite space junk, and roughly 40% are operational. Over the coming decade, it's estimated by Euroconsult that 990 satellites will be launched every year. This means that by 2028, there could be 15,000 satellites in orbit. Plasma physicists warns that the growing number of satellites burning up in Earth's atmosphere could disrupt the planet's magnetic field. According to The Guardian, scientists are concerned about the dust and ash created by burning satellites accumulating in the ionosphere and magnetosphere. Earth's lower orbit, already crowded with tens of thousands of satellites, may soon choke with many more, underscoring a need for stringent laws regarding the use of shared orbital space. More specifically, experts believe more than 1 million satellites are headed to low Earth orbit. These conductive materials could create charging effects and act as a magnetic shield, potentially weakening or deflecting Earth's magnetic field. We could get to 100,000 satellites in 10 to 15 years. Those satellites power hyper-connected internet services and may turn some billionaires into trillionaires at the cost of shrouding the planet with toxic trash. The vast majority of the increase is due to SpaceX's Starlink network, which offers broadband, satellite-based internet services. SpaceX now regularly launches more than 50 satellites at a time on its Falcon 9 reusable rocket. The magnetic field protects Earth from harmful solar radiation and is crucial for maintaining the atmosphere. The current amount of trash in the ionosphere already shows an apparent human-made electrostatic signature. With companies planning to launch tens of thousands of satellites in the coming decades, more research is needed to understand the potential impact on the magnetosphere. Space companies should be required to study the environmental impact of their satellites before launching them. Scientists are urging a re-evaluation of satellite internet until the potential risks are better understood. Space companies need to stop launching satellites if they can't provide studies that show that their pollution will not harm the stratosphere and magnetosphere. Until this pollution is studied further, we should all reconsider satellite internet. We need to address space debris so that space is sustainable and remains a working environment. The rapid increase in constellations comprising large numbers of satellites pose serious environmental hazards in space and to the atmosphere. But mitigation is challenging in large part because there hasn't been enough research on what can be done. Scientists explain 3 primary threats from that explosion of on-orbit activity: an increase in orbital debris, harmful emissions into the atmosphere from more launches, and the disruption of astronomy as satellites reflect sunlight or cause a cacophony of radio signals. And the Congressional Watchdog Office suggested a number of policy options that US government policymakers could take to mitigate those risks, ranging from funding expanded research to increasing data sharing to setting new standards and regulations. Of those three threats, the dangers of orbital debris are the most well understood and the problem that the scientists have been most active in attempting to resolve. Our space economy is moving fast. The second space age is here. For it to continue to grow, we need to do more to clean up after ourselves so space innovation can continue to respond. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.